Okay, here we go. So, quick review of some of the stuff we talked about last day. We were talking a little bit about first of all, we did all the first day procedure and course outline and all that thing. We talked about the scientific process. Basically, you ask a question, deciding what you want to measure. It has to be a question that's answerable. So there are plenty of questions that we can't deal with the scientific process because there's no way to measure. Are there ghosts? Well, I don't think there are, but it's tough to disprove, although I'm fairly certain there are not. There's nothing there to measure. You come up with a good question, and then you create an educated guess. The fancy word for that was a hypothesis. You make a prediction, and then you try and come up with an experiment. You want to have some things that you change. Those are called variables. Ideally, a good experiment only has one variable. Everything else stays the same. Then you can say whatever result you get probably is focusing on that one variable. And I mentioned yesterday, that's really, really tough to do in real life. In a good experiment, to get it down to one variable is very, 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 very difficult to do. So we talked about a few examples. We talked about independent variables and dependent variables. The independent ones, those are usually the ones you're changing from experiment to experiment to experiment. The dependent one, that's usually the one that you're measuring. You want to see, for example, I gave you the question of does how long you cook something affect the doneness? How long you cook it, that would be what I'll cook it for half an hour, I'll cook it for 33 minutes, cook it for 35 minutes, cook it for 36 minutes. The dependent variable will be how done it is. And then I left off with qualitative and quantitative, and I think I said both of them unfortunately begin with a QUA. Hello, just give me 1 second here. Hang on, just give me 1 second here. So both these words begin with a QUA, but hopefully you all know the word. You don't need to write this down. Oh, let's bring my pens up. Hopefully you all know the word quantity, which means how much or how big or how large. It's kind of a number-oriented word. And hopefully you all know the word quality, and those make up the root words of qualitative and quantitative. So what are we talking about here? Are you ready? Pick your pencils or your pens up, start writing. Qualitative has to do with I'll type this because my handwriting is so atrocious. Can I get it in the right? There we go. With a property that can't be measured with a number. As an example, blue, color. How blue is something? We can say dark blue or light blue, but you can't say that blue is worth 81 and that blue is worth 74. And you know what? That blue over there, that's a 19. So color. What else? I'll give you another one. Oop. Magnetism. If something's magnetic or not, it is or it isn't. It's not like, oh, it's kind of 30% magnetic. That's kind of a fancy word, a binary condition. You either are or you're not. The state of an object. Now, that's a word you learned last year. You learned that there are 3 states of matter. That's a lie, by the way. There are 3 main states of matter, but there are other weird, funky states that we can create. Who remembers the 3 main states of matter? I'll give you a hint. Solid. Okay. So let's go solid, liquid, gas, but you don't rate it with a number. It either is solid or liquid or gas, but you don't measure with a ruler or a number, like 73 solid. Texture. So these are things that we observe, smell, shape, but we can't really quantify them. Then there are some things that we can measure. So a quantitative idea contains a measurement. "10 minutes, not 11 minutes, not 9 minutes. You started your stopwatch and it ran for exactly 10 minutes. You measured it with a stopwatch. 19 grams, 33 centimeters. Those are quantitative values. So I wrote here, identify the following as qualitative or quantitative. Now you can write qualitative or quantitative, but I think I said to you yesterday, I am totally good with you when you're doing notes, finding clever abbreviations. So I decided QL for qualitative and QN for quantitative. I can't just use Q because they both begin with Q. So a 2-letter abbreviation is better than writing out the whole thing. Thank you, sir. So what you want to ask yourself is, which one of these is just telling you kind of yes or no? Which one of these is actually giving you a value? 1A says the bowling ball is heavier than the basketball. 1B says the red ball weighs 5 grams more than the blue ball. Which of those do you think is quantitative? Which of those do you think has a measured value? You're right. I think you said an answer. No? Yeah, you said B, ow, ow, B, ow, ow, B. Yeah. Yes. Okay. So apparently you find the letter B painful. That would be a quantitative measurement, not a qualitative measurement, because you can't measure how painful the letter B is to you. So her hair got stuck in the chair, I think, right? And this one, sorry, I wrote it wrong. This one's quantitative, you said. This one's heavier, I can feel that, but how much, don't know. 2A says the temperature, can you guys read? Well, you have it in front of you, but I'll zoom in and make it a bit bigger. It says the temperature increased by several degrees, or the temperature increased by 2 degrees Celsius. Which one of those is measured exactly? Which one of those is quantitative, a QT? Yeah, B. By the way, they're not always this easy, but I'm starting the shallow end of the pool before we get into the deep end, right? And this one would be it got warmer. Qualitative.
Hey, excuse this interruption. At
Pause
this
for a
time,
second.
Miss.
Keep going. Number 3. The water was lukewarm. B. The water was cooler than the oil. This is a trick question. Which one of those is measured? Which one of those has specific values? None of them. These are both qualitative. You're comparing, but you're not measuring. Yeah, qualitative. A, the color changed from blue to green. B, the sound became louder as the vibrations increased. Again, for it to be quantitative, you're saying, did they measure something and give you some kind of a numerical value? That's why I started with that question, because qualitative, I kind of say, well, if it's not measured, then it's qualitative, is my kind of real approach. Do you see something that was measured in 4A or 4B, a specific numerical value? No. Nope. Because it says it went from blue to green. How green? Dark green? Light green? Well, and even that's qualitative. Measure green. We don't know how you measure green. What do you think? Read 5A and 5B to yourself. Which one do you think has a measured quantitative value? B. So this is quantitative. What about number 6? Yeah. Both measured. Both measured, right? Because 9 minutes is a measurement, and 2 hours is also a measurement. Is that okay, Dan? Make sense? Thumbs up? Yep. Okay. Let's talk about independent and dependent. We're going to go a little bit further, and then I'm going to let you work on this next. By the way, the assignment is tricky. There's just no way to really water this down. When we go over your answers on Tuesday, I'm not going to be marking you wrong or right. It's more going to be, that's a pretty good idea. That one is a little murkier. But let's finish this off first, and then hopefully you'll get the rest of the class no homework. Independent and dependent variables. I talked about that a little bit already. So The blank variable, the independent, I'm going to abbreviate independent with IND. What would be a good abbreviation for dependent? DEP, okay? So I give you permission to do that. Is the variable, it's the one that you, the scientist, change. Fancy word, manipulate. It's the one that you have control over. It's the one that you build the experiment, and it's the one that you say, this is the one that I'm going to tweak every time I redo the experiment. The dependent variable, DEP, is the one that changes as a result of what you did. It depends on what the first one happened. That's why it's called dependent. And usually, the dependent variable is the variable that you are measuring or observing. It's usually the point of what you're trying to figure out. So at the beginning of this lesson yesterday, you may recall, I asked the question, does sunscreen prevent sunburn? So it might be you could either apply the same amount of sunscreen and expose the skin to the direct sunlight for 15 minutes, for 20 minutes, for 25 minutes, for 30 minutes, and then the independent variable would be time. The dependent variable would be then you'd measure how sunburned the person got, if at all. The controlled variable would be I want to use the same amount of sunscreen every time. Or you could have the same amount of time. I'm going to expose them for half an hour every time, but I'll vary the amount of sunscreen, and I'll measure how much sunburn they get. Example, hypothesis. If I eat more chocolate, then I will get zits. What is the independent variable? What's the one that you have control of? Yeah, how much chocolate I eat. Bet you want that snack now, don't you? Sorry. Chaka, spell it right, Mr. Dueck. By the way, if you're bored, go to YouTube sometime and do a search for farmers tasting chocolate for the first time. There was a great documentary that came out this summer. Chocolate farmers in the Ivory Coast in Africa who are very poor, who they farm the cocoa beans and they dry the cocoa beans, but they've never actually tried chocolate. And in fact, they didn't know what cocoa beans were used for. They thought it was used for winemaking or something like that. And when you see these 45-year-old men taste their first bite ever of chocolate, their face goes like they're 6 years old. Wow, oh, this is good stuff. So if you're bored, good documentary. Completely nothing to do with this, but. The dependent variable. Okay, so how much chocolate I eat might affect what? Looking at the hypothesis. You think you're looking for a word that has a Z? Yeah. In this case, though, that's not that was the hypothesis from yesterday. What's this hypothesis? It's a word that begins with a Z, I think. In fact, you know what? I think the dependent variable would be number of, and because it's a number and you're counting, that could be quantitative, right? Maybe no chocolate equals no zits, lots of chocolate equals lots of zits. Maybe this is the result or what you're measuring. By the way, most studies have shown that face acne has nothing to do with your diet, right? It's just being a teenager, and stress apparently brings it on. So eat what you want within reason. So I said here, use logic to fill in the blanks. So here's the hypothesis. If I give a plant fertilizer, then it will grow bigger. Probably a true hypothesis. What's the independent variable? If I wanted to prove this, what's the variable that I would manipulate? Yep. Mitra, yes? Yep. And that one I would probably measure. It would either be measuring how many liters or how many kilograms or how many, but that would probably be a quantitative, a measured variable. Keep going. What's the dependent variable? You're on a roll. You can do it. Yep. How much growth. And that, too, I probably could measure. How would I measure how much a plant has grown? A basic way might be to use a meter stick or a tape measure and just measure how tall it is. Now, that wouldn't necessarily measure the thickness. Oh, but I could also use a tape measure to measure how thick around the plant got. I could even count the number of branches or the number of, there's all sorts of quantitative ways that I could measure how much a plant is growing. Or at the very end, I could rip the plant out of the ground and literally weigh the sucker, right? If it was a plant that you knew was going to be like harvested anyways. If I wash the dishes with lots of soap, then they will be cleaner. What would the independent variable here be? Hudson. Okay. Amount is the fancy science word for how much? Amount of soap. Keep going, Hudson. What's the dependent variable, my friend? Now, how clean they are, do you think that would be quantitative, or would that just be kind of an observed qualitative? I can't come up with an easy way to measure cleanliness. For people, you can, right? It's how close people are willing to sit next to you. That determines your cleanliness. How clean they are. Some of you, oh, that explains, yeah, how clean they are. Hey, you guys shower once a week whether you need it or not. It's all good. Okay? And then there's a third type of variable. Hang on a second.
We're ready now to call our next group down for full.
So, item 4 is actually the biggest challenge in any experiment. And these are the controlled variables. That's a fancy word for these are the things that need to be kept constant. Giovanni, this is why medical research is so tough, because in medical research, the experiment is human beings, and none of us are the same. This is why you'll hear 1 year, oh, if you eat thus and such, it's good for you. And then a year later, you'll hear, well, no, now research has said if you eat thus and such, it's not as good for you. Did I remember to press play on the video? I think I did, right? Yes, I did. Really tough to do. In fact, the people that are good at this are legendary. When we do the electricity unit, I'll probably talk about Michael Faraday, who experimented, who discovered, who developed almost all of our electricity infrastructure. So he invented the electric motor and the electric generator from which all of our society derives. We call him the great experimentalist because he wasn't a very good reader. He had almost no math skills. But if you needed somebody to come up with a complicated experiment that could hold 80 variables constant and isolate just the one thing you were trying to figure out, he was your man. He was amazing. One of my science nerd heroes died about 140 years ago. So, example. The fertilizer one that we were talking about. So if you give fertilizer to one plant and nothing to the second one, what are some other conditions that you might need to keep constant so that you could tell if it was only the fertilizer that was making the difference? Use your brains, use your science nerd knowledge. What do you think? Oh, I heard someone say a T word. Yep. If you did one experiment where one plant was in a greenhouse and the other plant was outside, that would totally invalidate the experiment. What else? Yep. You guys have learned the abbreviation for water, yeah? H2O. You'll find out why it's H2O this year. What else? Sunlight, which would be, well, I was going to say, which would be tough. You know what? The easy way to do it would be to have both plants side by side next to each other, and that would probably, hopefully, take care of itself, but absolutely, sunlight exposure.
And our next call,
What else? You know what? If you were really wanting to do this, I think even the size of the pot for each one, if you had one in a big pot and one in a small pot, maybe the bigger one was able to grow because it had more room. I don't know. Type of soil. You'd want to probably take the same bag of soil, shake it, and then split it in half, and then you'd probably have the same type of soil. And we're just scratching the surface, by the way. There's all sorts of other things. Hey, maybe one is exposed to a breeze and one is not. You'd have to make sure that it was protected from the wind, because you've seen, for example, on the prairies, trees that are exposed to a wind don't grow as high. So even this really quite simple experiment, there's a bunch of things that suddenly you need to take into account. And again, as I said before, this is why medical research is seemingly so contradictory. Turn the page. Nerd comic says this: why did you build a death ray? To take over the world. No, I mean, what mad hypothesis are you testing? Are you just making mad observations? Look, I'm just trying to take over the world, that's all. You're at least going to have some of the world as a mad control group, right? Sad truth, most mad scientists are actually just mad engineers, because they're not testing a hypothesis. They're just building weapons. Nerd joke over their heads. Okay. Note to self. So this is what you're going to work on for the remainder of class. This is what's due Tuesday. Now let me talk about what I mean by due Tuesday. Folks, I do not take marks off for lates. I don't. What grade are you in? 9. You need to start to motivate yourself and get the homework done. So here's the deal. The consequence in my class for not doing the homework is you're doing the homework. You're not getting out of it. That means if you somehow think you're going to outlast me, you will not. That means if you think, well, I just won't do it, and eventually Dueck will ease up. No, I'll have you in after school. I'll have you in on a Pro D day. I'll have you in on the morning of parent-teacher interviews. I swear to you, the final week of June, I will have you in here doing the homework. I swear to you, I know where you live, and I'm nuts enough about teaching. I'll call you in July, explain to your parents that we can improve your grade because you're missing some homework. I'll open the school, and I'll get you here if I have to. I don't take marks off for late. You're going to do the homework. So when I say something is due, what I'm saying is this. Probably if you get it due for Tuesday, you won't be overwhelmed by homework later on in the week. You don't want to be one of those people who puts everything off, everything off, everything off, everything off, and suddenly has 10 straight hours of homework. Maybe you are. I'll try and break you of that habit as well. So I'm going to say this is due Tuesday, but if you don't understand it or you have some questions, you can still hand it in Thursday. Heck, you can still hand it in at Christmas for full mark. You can hand it in whenever. The other consequence, of course, though, is if you're doing the homework in June, why do I assign homework? So you can get it done. No. I don't assign homework so you can get it. In fact, I will never, ever, this is my promise to you, I will never, ever give you a homework assignment to shut you up. I think that's terrible. I will never do that. Why do I assign homework? Okay? Remember my speech on the first day, Act Like an Adult, and I said this is like a workplace environment, and I think I even said I pay you in marks. Your biggest marks come from tests. 70% of your grade comes from tests. The homework is to give you a chance to make all of your mistakes when it doesn't count.
At this time,
hang on.
Any grade 10s that have been missed, and
I give homework. Giovanni, every mistake you make on a homework or on a practice quiz is a good thing, because you probably won't make it on a test. I will almost always, this case no, but I will almost always give you the answers to the homework attached. Go ahead and cheat. Homework's worth 30% of your grade. If homework is worth 30% of your grade, what percent are tests worth? Do the arithmetic. 70. Go ahead and cheat on 30% and flunk the 70%. You've got far bigger math issues than just doing the homework, believe me. And I had a kid last year who did that every time. It was obvious. Getting 100% on all the homework, flunking every test. Never figured it out. Okay. Go ahead. I want you to learn how to learn. So, when's it due? Tuesday. Can you hand it in Thursday? Absolutely. Can you hand it in later than that? Sure. Just don't fall too far behind. Does that make sense? All right, let's talk about the assignment. This is kind of tricky. You can work with your person sitting next to you or in groups of 3, but you'll have to hand in your own assignment, but you can discuss this with your neighbor. Little Simpsons science. So, it says this. Smithers thinks that a special juice will make his workers work faster. There's his hypothesis. Juice makes workers work faster. He creates 2 groups of 50 workers each. He tells them to staple a set of papers. Group A is given the special juice to drink while they work. Group B is not given the special juice. After an hour, Smithers counts how many stacks of papers each group has made. Group A made that many stacks. Group B made that many stacks. One says, what would be a good title for this experiment? I'm not going to mark this right or wrong, but a good title for this experiment would not be Harvey. Give it a title, not a name. Like, does juice improve worker efficiency? Or something like that. Write the objective. I've kind of given you a hint in the title. What's his hypothesis? I'll let you think about what he's hypothesizing. List what you think some of the materials you would need are. Again, I'm not marking this right or wrong, which is why this time I haven't attached an answer key. What's the control group? What's the independent variable? What's the dependent variable? And are there any other variables that you think Smithers would have to control to make this a fair experiment? And based on the data, what should Smithers' conclusion be? Then we have a little Homer. So Homer notices that his shower is covered in a strange green slime. Slime. Sorry. His friend Barney tells him that coconut juice will get rid of the green slime. Homer decides to check this out by spraying half of the shower with coconut juice. He sprays the other half of the shower with water. After 3 days of treatment, there is no change in the appearance of the green slime on either side of the shower. I couldn't fit this all on one page. So what would be a good title? Write the objective. What's his hypothesis? List some materials. What do you think the control group is? Independent, dependent. See if you can come up with this. This is tough. This is very abstract. So if you find this nasty, congratulations, you're normal. I'm not going to test you on this. Then we have crusty itching powder. I'll let you read about crusty brand itching powder, see if you can identify that. And then Lisa is working on a science project. She wants to answer the question, does Ragouti, which is a commercial hair product, affect the speed of hair growth? Clearly, she loves her dad very much if she wants to work on a hair growth project. Okay? On a separate sheet, I wrote here, describe how Lisa would perform this experiment by writing a step-by-step procedure. You don't need to use complete English. You don't need to have it really, really detailed. Just list what you think are some things that she would need to take into account and how this one might work. Does that make sense?
Yeah.
Any questions there?